Good evening to all. Myself Renar Kumar from AC Department. So in this video, we are going to see transfer function in control system modeling. So there are some two transfer function. Either it may be input signal or output signal. So input can be notified as U of t, and the output signal can be notified as Y of t. So in this in between plant, so plant is like a controller. The controller can control the input signal, and it may be given to the output signal with the help of this controlling enable signals. So we are going to see how the signals has been converted to the system functions. So especially for Laplace transformation, we have to convert the concerned input as a transfer system. We are going to convert the input signal into the concerned system functions. Especially for this control system functions, this Laplace transform playing a vital role. So because based on the Laplace transformation, we can get the concerned system functions. So let us consider an example of U of t input signal Laplace transform U of t equal to U of s, because S is nothing but system functions. So these are some examples while considering a transfer functions. The next one is transfer functions, input and in terms of Laplace transform. So this type of system can be converted into the but initially we are going to take g of t is equal to output. G of t is a transfer function. The g of t equal to c of t by r of t. C of t is equal to output and r of t is the input. So this common block can be converted into the Laplace transform by g of s, because s is nothing but your system function. So g of s equal to c of s by r of s. While considering a Laplace transform, we are going to make a system function. So g of s equal to Laplace of c of t. Laplace of c of t and Laplace of r of t will make as a c of s or r of s. So like that we are going to see g of s equal to y of s by u of s. And next one is example. Let us consider an example of output signal. Here we are going to consider how the input signal has been converted into the Laplace transformation. So initially we are going to write the signal by input VIT, input signal as VIT equal to RIT, so resistor RIT plus 1 by C integration of I of t, because whenever we have considered a capacitor, we are going to like a capacitor value like the formula by 1 by C, the integration of I of t into dt, because while considering a capacitor circuit, the current may be flow into this capacitor circuit, so that we have to write the concerned parameter like this: 1 by C integration of I of t into dt. Next one is output signal. Output signal is nothing but Ri of t. So it can be converted into a Laplace transform by VIS, Laplace transformation of VIT, Laplace transformation of output voltage V naught of s, so that we can get R1 of s plus 1 by Cs I of s. So like that we can get RIS. So finally we are going to see how the transfer function has been enabled by this circuit. So the transfer function can be calculated by output by input V naught of s divided by V naught of s divided by V of s, so that we will get V naught of s equal to R divided by R plus 1 by Cs. So like that we have to calculate the concerned Laplace transformation for electrical circuits. So it will be a second example of confirmation of a Laplace transformation. So initially we are going to take V input voltage, and next we are going to take output voltage VIT equal to R1 here, so R1, so that you can take R1 into the current can be flowed towards the circuit, so that we can take it as R1 into I of t plus resistor 2 also, that the current may be flowed to the circuit, so we can take R2 into I of t. So after that, the properties of the capacitor is 1 by C about integration, the current also flow to the circuit, so I of t into dt. So output voltage can be calculated by, so the concerned circuit can be connected towards the output signal. So here the output can be connected by R2 and C. So we can take it as R2 into I of t. The same current will flow towards the circuit. So we have to consider the resistor 2 terminal also. So R2 into I of t plus 1 by C into I of t into dt. So we are going to calculate the transfer function. The transfer function can be calculated by V naught by Vi, so that we can get the concerned system function. So V naught already we know that the R2, so V naught equal to R2 1 by C I of t, 1 by Cs. So because after cancelling with each other, the remaining term will be R2 by R2 plus 1 by Cs, R1 plus R2 plus 1 by Cs. So the Laplace transformation is necessary because we are going to get the output by system function. So in order to transferring the signal by a system function, we may go for this Laplace transformation. So some of the properties are there for converting a signal in one signal into another signal. So one of the example is sine omega t, because sometimes we may get some signals like sine or cos or tan signals. So in this case, we are going to take it as a system by sine omega t equal Laplace of sine omega t equal to omega by s square plus omega, because already we have told that we are going to calculate only the system transfer function. So it is possible only by using conversion of Laplace transformation. So there are some properties, Laplace e of e power minus at 1 by s plus a. So like that, some of the examples are there. Here we are going to see how the Laplace has been played to convert a signal. So next one is differentiation. While considering a Laplace transform in a differentiation part, the same concept will be implemented here also. Laplace of differentiation x of t into dt divided by dt s into x of s, because we are going to calculate the system transfer function. Like that, we are going to take s into x of, because one differentiation means s, the power is 0, s into x of s minus x of 0. And next one is d square x of t by dt square. So here that they are taken as double time the differentiation. So automatically the system function will be a s square, because here d square will be there. So the transfer function also s square into x of s minus s into x of 0, because it is a double time differentiation. So in previous case we have discussed, for a single differentiation we can take it as x into x of s minus x of 0. But in this case the formula will be a s square x of s minus s into x of 0 minus dx of 0 by dt. So while implementing the control system, we are going to take it as an example like a into d square x of t by dt square equal to c. So like that we can have a output of the corresponding system function. So this function can be written or a of x double dot, because s double dot means it also known as d square, because so that we can take it as we can reduce the steps a x double dot t. So taking the Laplace transform of either side, we can get the system transfer functions. Thank you.